Hello class. I just wanted to show another video to be very thorough with what I'm expecting on some of your homework. So just to give some more examples of how to calculate things, we have two other videos talking about how to determine the number of protons, neutrons, electrons, giving the atomic weight and atomic number. But I also wanted to just be clear and go through a few examples with everyone. So we have a nice example of oxygen right here. So oxygen's atomic number is 8. That means it has 8 protons as well and 8 electrons. Then by looking at our periodic table, we can find oxygen right here, and it has 15.999 atomic mass units for its weight, or 16. So by doing 16 minus 8, we get 8 neutrons. So that's our example. I'm going to go through the next one. So just to be clear, the information given is 22 is the atomic number. That means it has 22 protons. And that also means it has 22 electrons. And then we can go to our periodic table and look for the number 22. 22 would be titanium, and its atomic mass is 47 point, we'll round up just to call it 48 to make it easy. So atomic weight is 48. We have titanium. I think it was Ti. And we always got to make sure we're spelling things right, which I struggle with, but yep, titanium is Ti. And then our number of neutrons is going to be 48 minus 22, which is also known as 26, I believe, if I'm doing math in my head correctly. So that's how we do a basic one. Just to refresh your memory, the ones I really wanted to show examples on are some isotopes and ions. So we have hydrogen for this example. You'll see these tables a lot because it's a good way to test your knowledge. So we have an atomic number of 1. So we go to our table and number 1 is hydrogen. Oops, sorry. That was our other example. Let's move that over. So we have hydrogen. And we have 2 neutrons. We know that because we have an atomic number 1, we're going to have one proton, and our electrons are going to be 1. And our atomic weight is always our protons plus our neutrons, so that is going to be 3. So we check to see if our atomic weight is the same, and our atomic weight is usually 1. So that means that our hydrogen is an isotope because it has a different number of neutrons than it usually does. The fact that its atomic weight is usually 1 means it has 1 proton and 0 neutrons usually. So this is an isotope. Let's look at another good example. We have 24. So 24 is chromium. It's usually at 52 as a mass. So this was chromium. I think it was Cr. 52, so 24 protons because it's the same as the atomic number. We are going to need 52 minus 24, which is going to be 28, I believe, if my mental math is correct. And again, we would have 24. Awesome. So this is just a simple element. Now, if we have an ion, we are going to look for our atomic number. So 26 is our atomic number. Our atomic number is iron. The weight is 55.8, so we'll round up to 56. And I think I said iron, which is Fe. Now, our number of protons are always the same as the atomic number. if we change the number of protons, we are changing the element itself. The number of neutrons is just simply the same as always, 56 minus 26, which is our atomic weight, minus our number of protons, which is 30. Now, here's the important part. We have to look at our electrons. We were given 24 electrons, but our atomic number is 24. So it should be our atomic number is 26. So our electrons should be 26, but since we're at 24, that means it's an ion. That means that we have lost 2 electrons to somewhere, we don't know where. But that is important when we come to name this iron atom. So what happens is we lose 2 electrons. So since electrons carry a negative charge, we're actually going to have iron plus 2. So I hope that makes sense how we got to there. I'm going to show you one more example. This is actually going to be on your homework. So let's try chloride. I think ions are a little bit harder than isotopes. So we're going to do chloride minus 1. So we have to actually, if we're given the number of protons, we know that the atomic number is 17. Even for isotopes and ions, the atomic number is always equal to the number of protons. Then we can even find out the atomic weight by adding our protons and neutrons. So 15 plus 17 is 35, I believe. And then our last thing is our number of electrons. So we usually have 17, right? Our atomic number is 17. Normally we would have 17 electrons, but chloride has a minus 1, making it an ion. So a minus 1 actually means we gained an electron because of the negative charge of an electron. Anytime our element is more negative than usual, we are gaining electrons. So our correct answer would be 18. So I hope that was enough examples, and maybe also introduce you to these tables that I will be using a lot to just have you fill out different elements and number of protons, neutrons, and electrons. As always, if there's any questions, please let me know.